Hey guys, welcome back to the Zenith Stratosphere porthole television restoration project. I'm picking it right up where I left off. Here it is the next day. We got it working in the last video, but we got some obvious problems. Part of the screen on the right hand side is darkened and we weren't able to get any reception. So I'm picking right up with troubleshooting now. I reviewed the brightness control and the video amp. Didn't see any obvious problems. I checked resistors, checked my work. Didn't see anything that jumped out at me, so I'm going right to signal injection. Right now, I'm taking my Suncor TVA 92, this guy in the bottom down here, and using the video drive output right into the grid of the final video amp of 6 AC7s, just going right to the grid. This TVA 92 is really handy because you can do signal levels from 0 to 300 volts peak to peak, both positive and negative polarity. You can substitute for the video signal the horizontal and vertical drive. Now, I don't know what the polarity or amplitude should be at this point, but I can tell you this, by applying it, we've got something more on the screen. So here it is removed, here it is injected, so clearly we are getting something through. Let's try to see if we can get it to lock. So that's vertical hold. That seems to be locking. Horizontal hold. No, this should be a crosshatch pattern. Yeah, we can kind of see it there. I'm going to switch to the Windows circle pattern. That might be a little easier to see what's going on. Turn the brightness down a bit. Or not. And here's contrast, which vary the gain, although we might be past the point where contrast does anything. Remember that when you inject signals and you're bypassing a bunch of stages, the controls might not necessarily do anything. Yeah, the contrast control varies the level into this tube, so we're bypassing it, so we forget about that. So we really just isolated it to the second video amp and the brightness control. And the sync signal is picked off from this, so we should be able to synchronize this. Let's try adjusting some of the horizontal coils. We've got frequency and phase, and then a horizontal hold control. But the horizontal hold control in the middle of its range and adjust the frequency. Usually that gets you in the ballpark. Core's pretty well in, so I'll try to back it out. As we go through and get to harmonics of the horizontal, we'll kind of see it, or we'll see multiple images. Eventually, oh, it's trying. Let's try adjusting phase now. There is a procedure for doing this outlined in the service info. I'm just kind of trying to eyeball it. Boy, that's how sync works when something's not right. Polarity, the signal level, or just flat out the phase discriminator's not working on the horizontal. Because if I adjust it manually, I can kind of get it, and then it goes away. Also, you got the brightness. So that's brightness all the way down, and still got kind of a bright background to it now. The joys of working with metal cone CRTs is we have a huge surface area with high potential on it on the workbench. I have to be very careful when I go try to manipulate controls. I'm starting to think I may be better off just removing this and going with a test CRT. I was hoping to get lucky in this would not require a lot of troubleshooting. Alright, so there's 0. Let's try the opposite polarity. Okay, well now the video is inverted, so clearly that's not right. We got a light background and a dark image, so it is right going this way. What I don't know is what should the amplitude be. I'm on the 3 volt peak to peak range. Let's go to the higher range. It's completely overdriven, so yeah, kind of seems like in the ballpark of 3 volts is probably right. So get this to lock better now. So vertical's no problem, but horizontals are so swirly. Oh man, this set is really starting to frustrate me. But I'm willing to slog through it because I need to circle back and finish off my porthole set with a very similar chassis eventually. So here's what I've been trying to do. Okay, it's tough to troubleshoot this with this big old metal cone CRT. See, I've got a very nice scope back here and other test equipment. If I hook up my scope and take the test lead and start probing around, I get anywhere near this, I could fry my scope. That would really ruin my day, or any of this other equipment for that matter. So I am trying to remove this, but it's getting hung up on the yoke, which is not as uncommon as I'd like it to be. These yokes can shrink over time, and what happens is that we've got this glass neck, and there's a bit of a lip here where the Bakelite base is attached. This lip gets hung up on the windings inside here, and it's not so easy to do when you're by yourself and trying to pull this out, and it gets hung up on that, and you're carrying the weight of this, and if you put too much force on the neck, you're going to snap it right off. And basically, since these CRTs are essentially irreplaceable, don't want to force anything. So for the time being, I reattached it. Alright, so I thought, well, we got problems with the tuner, right? Let's look into the tuner. So, hey, there's some screws up top. We take those off. Oh, that didn't do it. Annoyingly, there's 2 screws down below, which are a little awkward to get at. Okay, cool, we got that off. We'll just take this cover right off. No. Because we've got this adjustable slug shaft coming down here. We've got this braided cable with 0 slack on it. I've been trying to finagle this and twist and bend and contort. It comes so close to coming off, but it just won't. I think I can work around that, though, because I can just get enough out of the way to look inside. Now, that's the power resistor that I've seen fried in some of these similar tuners. This is a bit earlier than some of the other ones I've worked on, but now visibly it looks okay, but of course I want to test it and test the other resistors. Not a whole lot going on in there. These are incredibly reliable tubular ceramic caps. Those aren't going to be an issue, but we want to check all that stuff. I've gone over the horizontal circuit and nothing jumped out at me. There are some mica caps, but they're down inside this assembly, which is kind of potted up in wax and mounted kind of strangely. So it's not an easy thing to get down into. I'd have to basically disconnect the wires and pull the thing out, melt the wax off, and get down in there, disconnect one end of the cap and check them for leakage. Hate to do it, but those are where the caps are for the horizontal discriminator circuit, so I may have to do that. But we'll do voltage checks, and I've checked the resistors, they're fine. I've swapped the tubes out, that's fine. I've checked the wiring, that's fine. But I'm taking a break from all that stuff to just simply do some cleaning, because that I know I can do, and it will make me feel better to actually accomplish something. So I did some cleaning on some other areas, but when I got to look at it this side is really nasty gross. So we're going to use some CLR, which I've talked about so many times before. It's calcium, lime, and rust. That's what the CLR stands for. It's a very common household cleaner in the United States. It's got gluconic acid and lactic acid. Those are the 2 active ingredients. Basically very mild acids that do a fantastic job cleaning up metal corrosion. This product is made for cleaning basically porcelain sinks, bathtubs, that kind of thing. If you've got minerals in your water, they can leave behind some stains or mineral residue when the water evaporates, and this dissolves it. But it also does a great job of cleaning metal. I've also submerged rusty metal pieces into it, and it works almost as well as Evapo-Rust. It also does a great job on this cadmium corrosion. Basically brush it on, let it sit a few minutes, wipe it off, do a second or third pass if you need to. Part of it's not just because it looks nice, is it when I grab this chassis and manipulate it, all this dust and oxidation is coming off in my hands, which is not so nice. It doesn't really get absorbed through your skin very readily. The main problems are if you ingest it or breathe in the dust. And by doing this, I get rid of the dust altogether, so it not only looks better, but it's a bit less toxic to handle. It may look a bit precarious the way I have this chassis, but it's stable. It's not going anywhere. So I still haven't decided what I'm going to do about the CRT. The safest thing to do would be to disconnect the yoke and just take it off with the pitcher tube. There's 4 wires going up to it. They're a little crusty, but I think that is the safest route. Another option could be to use a heat gun or hair dryer to heat up the yoke, which may allow it to soften a little bit so I can pull the CRT up. I'd rather not mess with that. It's really packed in there between the CRT bell and the focus coil, so it'd be a little bit tough to heat it up in place. And as a customer said, I really don't want to take any unnecessary risks, but with this out of the way, I can use a little test CRT to make troubleshooting signal injection probing around so much easier. I was also wondering if this set had an AGC control, and yes it does, it's down here. I did play around with that a little bit and made no difference. Still not getting any signal coming through the tuner up through to the CRT face. Here's how the side looks after a couple passes with the CLR. I think I'll do one more. I would say that's a pretty darn good improvement. I will wipe down the rest of the top of the chassis in a similar manner. Where there's a will, there's a way. Yeah, disconnecting the 4 yoke wires wasn't the easiest thing in the world, but I was able to trace out the wires and took notes about where they reattach. I was able to take off the entire thing, and once I had it out of the chassis, it was actually quite easy to get the yoke off. And notice the base on the CRT is a bit loose, so I'll take care of that while I've got it all apart. Now I can get a town on it. 1, more cleaning, and 2, I can get at everything now more readily for troubleshooting. And another thing I like about these early porthole sets is the high voltage lead is pretty much compatible with the standard button type CRTs. Here, I'll show you what I mean. So here's a little 5AXP4 CRT I will be using for troubleshooting, and it's a little loose, but it snaps in there. Later ones used a clip that clips onto the rim of the metal CRT bell, which is totally incompatible with this, and I've had to rig up little connectors to keep it on there. Well, I can finally see some of the stuff. So these are the caps I was struggling to get out. See, even with the CRT out, yeah, I mean, yeah, you see, you could get a hacksaw blade in here and cut these open. But now, of course, since I took all that out, I could take this stuff out of the way, because I still got the gigantic tuner in the way. Anyways, if nothing else, now I can do a whole lot of cleaning. There's those big porcelain CRT standoffs. And replace the fine-tuning of dial cord. Just do this long shaft down into the tuner. It's also quite stiff, and if you're wondering what does that actually do, there are these little offset discs of metal that sweep through here and form a variable capacitor as this rotates around. It's really hard to turn, so we gotta get some fresh grease in all these points and can lube up this whole channel clunker assembly here. So what I'm getting at is, yeah, it's a pain in the ass, but it does make completely overhauling a chassis a lot easier with it out of the way. Probably should have just done that from the beginning. Alright, rigged up the little 5AXP4 test CRT, and now we all want to know, do the same problems exist with this? Absolutely. This is brightness all the way down. You turn it up, it just sort of blooms. It doesn't do what it's supposed to do. And we have the right side dark. So, got some comments saying, hey, is the image just shifted over? No. Like the circle's basically centered here, the right side is dark. And it's stable for the moment. That's only because I've been very careful adjusting the horizontal phase, but it's very, very, very touchy. The horizontal hold is not locking like it's supposed to at all. So it's good, because it means we can do all our troubleshooting with the little test CRT, and there's nothing wrong with the full-size CRT, which is definitely a possibility. For the most part, the voltages I've checked so far are pretty close. So we should have 190 on one side of this resistor and 250 on the other. So there's our 250. Pretty darn close. 190 and 250. I mean, that's within, what, 1% or so. The brightness control, it's off a bit. But the thing that's really jumped out at me that's off significantly is the boost voltage, which is going to this power resistor here. It should be 510. And it's 430, so it's about 80 volts off. Not tremendously, but that goes right to G2 on the CRT. It would have some effect on things. So why would it be off? Well, that's the one power resistor that's original that I left. We can swap that out. Also, the 5V4 damper tube is the original. Tested good, but we can swap that out. As far as the voltage being a little off on the brightness control, well, there are some resistors going to it, like there's an 82K down in here. It's drifted up slightly. It's also going to that 100K down in here. I think this goes right to one side of the brightness control. 244. Did I show what that should be? No. Well, actually, yeah, I mean, so if the wiper goes from 120 to 250, so let's check what the voltages are on either leg of that. So on one side, we have 169, and on the other, we have 243, so it's off a bit. Alright, now that I can more safely use test equipment, I think I'm on to something. So right now I have no signal going into the set, and we've got that shading on the right hand side, and the brightness control isn't doing its thing. Alright, so the first thing I did is I fired up scope and put the scope on the wiper of the brightness control, and I saw a waveform that looked similar to that. And I've been sniffing around to see where that might be coming from. It's not coming through from the video amp. The grid is essentially flat. There's no signal coming in there. It's coming through on the brightness control. So I'm like, okay, what does that go to? Well, it's a potentiometer. One side of it goes via an 82K resistor to ground, so nothing coming through there. Okay, well, what about some of this other stuff? It gets a little confusing as it hooks up to this phone vision socket, which was a system for watching pay-per-view movies. We'd hook this up to the phone system, but when you're not using it, there's this dummy plug that plugs in there and kind of bypasses stuff. And that's what this 0.033 microfarad cap is going down to. The end of it should be getting grounded via that shorting plug. But so I started expanding it, and I'm looking at this 6200 ohm resistor. That's this guy sitting out right here, and that's also got that strongly imposed waveform on it. So now I'm tracing out, well, one end of that goes up here. It goes down to this bus that's going along down here. which is supposed to be plus 250 volt bus. I'm pretty sure it should just be clean DC. And it's 5K resistor going, it's a plate load resistor in the horizontal oscillator tube. Now there should also be a 40 microfarad filter cap going from that to ground, which should swamp that out. And that, by the way, is a horizontal oscillator frequency. So I gotta check that I not hook that electrolytic cap up, or what, because I got the scope at this point right now. And pretty sure that should just be straight up DC voltage right there, and we've got that waveform kicking out. So I need to trace out these wires, and because it kind of goes all over the place, because that 250 volt bus powers a bunch of stuff, and then that's the horizontal oscillator tube there. So I'm thinking that the oscillations coming out of that tube are working their way into other circuits where they most definitely should not be. Hey, I think I found the problem. So coming off of this junction here where I got my scope probe, we're seeing that strong waveform. I got this wire going up here. It's going to nothing. That's that cap, that filter cap. It's going to this point. I disconnected this wire and never hooked it back up. Alright, let's get that reattached, see if the problem goes away. Alright, I got the wire reattached. And I am now injecting a signal again. Test pattern to the grid right at the video amp. Just turn the set on. Trace one off the top of the scope as it warms up. Got it AC coupled, so it came back down, and there's no pulse on it anymore. And hey, look at that on the screen. It is a nice, stable image. No shading on the right, and it looks crisp. See what that brightness control, it's all the way down and up. Kinda, the video camera is reacting because it's trying to compensate for the brightness level going up. Well, all the way down, I would have thought it would extinguish it, but we'll get there. I might be feeding in too strong of a signal. I'm not worried about that right now, but obviously that problem was gone. Let's see if we just horizontal centering. Oh, sorry, let's focus. Horizontal centering, I think. Yep, there we go. Cool. Well, that seems to have solved the problem. Horizontal hold, rotating that control through its range, and we are not losing sync. It was so unstable before. The service info says you should basically go through from one end to the other, the hold control, and you won't lose sync. And yeah, all right, that solved it. Fantastic. Didn't have to waste too much time on that. And with that big CRT out of the way, I can clean the chassis. Plus, we still have not gotten a signal to come through the tuner yet, so we'll work on that next. Now, I gotta say, I have followed plenty of other restoration threads, especially on the Antique Radio forum, and often, more often than I think most people would like to admit, problems come down to mistakes during the restoration process, during the recap process. It's annoying, but it's just my feedback from watching many people struggle, where the experts will weigh in, and I think part of it is they're hoping it's something unusual, exotic, where you need to break out the test equipment and do elaborate procedures. But time and again I've seen it, people make mistakes. I made a mistake. It happens all the time because I replaced a whole bunch of parts. In fact, obviously I've been doing this a long time, that I only seem to have made one mistake, but you can imagine when you replace like upwards of, 50 plus capacitors, mistakes are going to happen. So that seems to have solved that. Now let's try injecting a signal through the tuner again and see where we can get with that. I popped the lid off the tuner and got some deoxid down in there, and also notice little numbers in the channel plate segments, like that's 13, that's 3, and I have 6 engaged. So now I'm pretty confident it is tuned to channel 6, so that's what I have feeding in from my test pattern generator. And check this out. If I get it just right, as I'm rotating the channel clunker, I get some reception. But if I actually lock it into the clunker, it goes away. Not at all unusual in these old sets. Tuner could be misaligned, it could just need even more cleaning. So that's kind of in between stations, and when I land on it, we get nothing. If I start going to the next channel, I kind of get something, and then nothing. I'm rotating the fine-tuning shaft now. Now. There's a few other things to play around with on this chassis. One, people have asked me, what the heck is this knob here on the spring? Well, you push that in, and it engages with a trimmer cap on each channel section, and so you fine-tune the local oscillator for just that channel section. You can imagine when the full-size metal cone CRT is in here, coming down to right about here to reach in with your hand and push this in and adjust this. The 12,000 volts right next to your knuckles is not much fun. Also, this is AGC control. And of course we got fine-tuning, and then there's contrast, and the contrast in this set is actually a potentiometer. It varies the video signal using a pot. It doesn't change. Some sets vary the gain on a video amp, but in this they actually just use it like a volume control essentially for the video. So we have contrast all the way up. Trying to keep the brightness down somewhat low, because if I turn it up real high it kind of washes out the detail. Don't know exactly how the AGC should be set, so it kind of seems like if I go fully clockwise I get more gain. Now let's try that local oscillator slug. I think I might be onto something here too. So I mentioned earlier, I think, that when I popped open some of these other Zenith tuners and these other porthole sets, I found a resistor that was burned, discolored, in one or two cases cracked in half. And that'd be this guy. And this one looks fine, but I just tried measuring it. I'm getting nothing. Maybe I'm not making good contact. Let's see. Keep this stuff in the frame while I tinker around. Going back to my Fluke 27 for this. Alright, so probes together. We got 10 ohms. I wonder if my battery's getting low on this thing. Well, anyway. So there's one end of that resistor. And here's another resistor. Alright, 132. And when I tried this one, yeah, nothing. Nada. Let's try this guy over here, which seems like 10 ohms. Boy. Alright, there is a new 4.7K installed, and for that 10 ohm, once I got it out of circuit and could test it properly, it was actually measuring 33 ohms, so I went ahead and replaced that. Now if you're thinking, hey, high frequency circuit, I used metal film resistors, that might cause a problem, I should use carbon copper, non-inductive. I've looked at the specs on these. We're talking fractions of microhenries, if even that. If we were in the gigahertz, absolutely. The tens or hundreds of megahertz, I've never seen it be an issue, so let's give this a try. Here we go again. Hey, alright. That's more like it. Let's see what channel we on. Channel 4. Brightness down, brightness up. Contrast up all the way, down. Right. Let's see, there's that expando switch. There's expanded mode, normal mode. Adjust this fine tuning slug again. Just put it in multi-burst pattern for that. See how sharp we can get this. Let's focus. Let's focus. Alright. Just going to get with this little test CRT for focus. Alright, that is going to be it for tonight. Thanks for watching.